at school. In today's lesson, we are going to learn about angles on parallel lines. And this is going to be lots of fun, and I'm going to show you why. But first, let us recap. Do you remember what parallel lines are? Parallel lines are lines that are the same distance apart and will never meet. A real-life example is railway tracks. In this example, we see that these two lines at any point between this red line and the blue line, we will always measure the same distance. And hence, we know that parallel lines are the same distance. But what's important is that they will never meet. These two lines will carry on forever, but they will never ever touch or meet. The same applies to railway tracks. In this case, at each point in the railway track, it is always the same distance apart and it will carry on and on and on. Those lines do not meet. So parallel lines are indicated by a single or a double arrow, such as in this case. Whenever we see these arrows, either it's single or double, this tells us that these lines are parallel to each other. So how are angles on parallel lines formed? Through a transversal. A transversal is a line that crosses at least two other lines. And in this example, we have a line that cuts two parallel lines in this case. We know it's parallel because of our two arrows, and this blue line that cuts the two parallel lines is known as a transversal. So when a transversal intersects two lines that are parallel to each other, angles are formed. Angles are formed between these lines. Sorry about that. And certain angles become equal to each other. The three types of angles on parallel lines are, therefore, I said earlier, I'm going to show you why it is fun. So the first one is corresponding angles. And with corresponding angles, the best way that I remember it is by identifying an F shape. So in this case, we are given two lines. And we know they are parallel because it's indicated by the two arrows here. And what's important is that with corresponding angles, it makes an F shape, and I highlighted it in red. Another thing that's important to note is that with corresponding angles, this angle will always equal to this angle. But when we're looking for corresponding angles, we will not always see an F shape the way we know it. It can be lying on its side, it can be facing upwards, downwards, or even flipped. So, in this example, what other angle can you see is equal to each other? These two angles would also be equal to each other because these two lines are parallel, and this is known as corresponding angles. Now time for an example. In our question, we are asked to find the value of the unknown variable. And in this case, what is our unknown variable? It is x, right? We are also given additional information. We are told that the lines are actually named in this case. The lines AB is parallel to CD. And how do we know this? Because of our two arrows indicated here. So when we inspect this diagram or this problem, what type of angles do you see? Immediately when I look at it, I see an F shape. So, which angles are equal to each other? 105 105 degrees rather is equal to x. So when we write our answer, we'll say x is equal to 105 degrees, and we always give a reason. And our reason is, it is because it's corresponding angles. And how do we know this? Because AB is parallel to CD. And when we write out parallel, this two strokes is the symbol for parallel. Right. Our next type of angles on parallel lines are known as co-interior angles. In this case, I always think of the U shape. Do you see where I'm getting at with my acronym of FUN? So with co-interior angles, we see a U shape, but instead of certain angles being equal to each other, in the case of co-interior angles, the sum of the two co-interior angles, and when I mean co-interior, it is the angles that lie within this U shape. The sum of it is always equals to 180 degrees. And this is known as the angles being supplementary. The sum of the two co-interior angles are supplementary, and that means it's equal to 180 degrees. So when you think of co-interior angles, think about the letter U. And again, just like corresponding angles, with co-interior angles, the U shape can be rotated, meaning it doesn't always look like our standard letter U. It can be lying on its side, it can be flipped, as long as you can see some type of U shape. But very important, the two lines need to always be parallel to each other, because this is all about angles on parallel lines. So time for an example. The question asks us to find the value of the unknown variable. In our question, the unknown variable is Z. What we have here is PQRS are the names of the lines. So we have a line named PQ and another line named RS. We are also given additional information that line PQ is parallel to line RS, and we know that because of the two arrows that are indicated on the lines. That tells us that these lines are parallel to each other. So now that we have established that, what else can we see? Can you see a U shape? Because I can definitely see one. So now what do we know if it's a U shape? We know that it is co-interior angles. And therefore, when we're finding the solution of this problem, with co-interior angles, we know that the sum of the co-interior angles are always equals to 180 degrees. Therefore, in our case, the co-interior angles is 60 degrees and the unknown angle Z. So 60 plus Z, 60 degrees plus Z is equals to 180 degrees. And we always have to give a reason. We know this because it is co-interior angles, and which lines are parallel to each other? It's line PQ and RS. Therefore, our reason will be co-interior angles PQ parallel to RS. But we have to solve for this equation. And how do we do that? To isolate the variable or the unknown, we take the constant to the other side, and then it will take the opposite operation, and therefore we have Z is equals to 180 degrees minus 60 degrees, and that gives us 120 degrees. So Z is equals to 120 degrees. Now for the last type of angles on parallel lines, this is known as alternate angles. And with alternate angles, I always think of the letter N. Do you see why I say angles on parallel lines are going to be fun? Because with corresponding angles, we think about the letter F. And with co-interior angles, we think of the letter U. With alternate angles, we think of the letter N. Now with alternate angles, the angle that I highlighted in blue with the blue dots will always be equals to each other. It's also important to know, before we can say these angles are equals to each other, we always have to first establish that the lines are parallel to each other. And we know this in this case because our lines have the arrows. This tells us they are parallel to each other. So with alternate angles, I always think of it as the angles being the angle in the corner of the letter N. That's how I remember it. I just think of the letter N and it will just tell me immediately these two angles will be equal to each other. But remember that this letter N can lie on its side, it can be rotated, it can be flipped, as long as you can identify it with parallel lines. So another way to think of it is, with alternate angles, is thinking of a letter Z. This angle will always be equals to that angle. So time for an example. Again, we are asked to find the value of the unknown. We are told that lines EF is parallel to GH, and we are required to find what is the value of Y in this case. That is our unknown variable in this question. So when I look at this problem, do you see something familiar? Because I do. I see a letter Z. And what does this tell me? When I think of the letter Z, this is co-interior. No, rather this is alternate angles. So that tells us 75 degrees is equals to Y. And when we write our answer, Y is equals to 75 degrees because it is alternate angles, and we know this because EF is parallel to GH. That's it, folks. Thank you so much for watching. Please help support me and like and subscribe.